Hi guys, today we're going to talk about indicators, part E, suitable indicators. What are indicators? Okay, what are they? What? Right? So how about the color? Why color change? Why color change? Of course, the indicators is for acid-base titrations. Okay, why color change and what is neutral point or equivalence point? Neutral. Okay, neutral point or pH. We call it equivalence point. Equivalence point. Okay, and of course we talk about the pH range of the indicators. Okay. And also then the choice of indicators for different acid-base titration. Of course, acid-base titration has four kinds. Strong acid and strong base. Strong acids and weak base. Weak acids and strong base. And of course, weak acids and weak base. Okay, so there are four kinds of titrations. So what choices of indicators are we to choose? Can we find or not? So from there we can plot what we call an acid-based. See here, okay. Well here, changes in pH. Okay, we call it a titration curve. Okay, we're going to plot titration curves. Okay, now let me show you what titration curves are. I've downloaded quite a lot of things in. This is the here. Okay, pH curve against the volume of base, which is anyway here, or acid. You look at the first part here. I got lots of them. Okay, all these are called titration curves. The change means the pH changes as the titration is increase in volume. Okay, of the base here or of acid, up to you. Okay, here is of the base, and the reverse here is of the acid. One here for acid here. Okay, so this is acid increasing here. Okay, it's going down here. Okay, so now let's look at first of all, before we don't delay anymore. Okay, what are indicators is in page 26. Okay, 26 of your main notes. So what are indicators? They are basically acid base, weak acid and weak bases. Okay, what are they? They are weak acids. Basically acids are okay. Weak acids means what? Means they are partially dissociated or ionized. Okay, dissociated or ionized. Means what? Means, let's say we have, what's inside water, right? We have our acid here, HA represents acid, right? I told you before, this is a general term. General or general notation for acids, okay? General term or whatever for acids, okay? Of course, it's mono, basically I don't care. So because it's a weak acid, it means it will dissociate to give H plus and A minus. That means that in a solution of indicators here of aqueous, this is aqueous indicator. Okay, indicators. And the indicator is weak acid of HA. Means got water, isn't it? That means it will dissociate. Okay, that means inside here got three species of the acid HA. Which one is undissociated? It's undissociated. Undissociated. It's a H plus, and of course your anion, okay, your anion from your acid, okay, right? Now, if it's supposed to be an indicator for acid base, then all acid and all bases are colorless, right? So to see the end point, which means the neutral point or the point where we assume is pH 7, it may not be pH 7. So we assume that with all the acid and all the bases, okay, when you titrate acid plus base, right, to give you what? Salt and water only, isn't it? So we assume that this one no more, okay? All with salt. It means at this point here, that means you call the end point. Okay? So at the end point, we say that, well, all the acid, all the bases have reacted. Right? So that means that how do we see if the salt is colorless, if everything is colorless, it's colorless, no color, no color, no color, no color. How do we see? We cannot see. So unless we have an indicator, which will tell me that the change of pH, right? Then I can say, oh, the end point is which all the acid and the base are reacted, right? So that's why an indicator must be colored in the acid-base titration. So now there are possibilities of two color. HA is a color, okay, and your A minus is a color, right? H plus is colors. So like for example, metal orange, okay, your famous metal orange, right? They found the HA is red in color, and the A minus is yellow. That's why you put metal orange into acid is red in color. You put metal orange into alkali is yellow in color. Okay, in a titration, all your titration happens at the middle point. Okay, the middle point. Okay, right. The end point is orange, which means this one is equal to this one here. Now we will see why. Okay, why orange? Okay, same thing here. Phenolphthalein HA is colorless. Okay, A minus is red or pink. Either one. If you use pink, always use pink. If you use red, always use red. Don't use pink and red. Pink and red, they give you 0. Okay, so of course the midpoint or the end point we call it is what is faint pink. Remember, faint pink, faint pink must be faint there. Okay, if it's too pink, cannot. It's all short already. Litmus, of course, HA is red and A minus is blue. That means that the middle point we call is purple. Right, purple would be the end point here. Right. Of course, nowadays for all titration in AS, we have your bromophenol blue or bromothymol blue, which is here, the A plus is your yellow, and this is blue. So the end point, remember, is what? Is green, remember now, okay? So this is the most famous phenol, here put here already, is bromothymol blue or bromophenol blue, also can, same, okay? Right? So this one is yellow and blue. Okay. So why is it color? Because of HA and A minus, or one of them or both of them. Right. So the middle point is when they are equal in concentration. You see why afterwards. Okay. So what's the indicator? It's a weak acid. Very important, weak, because then you can have three species: HA, H plus, and A minus. Okay. So what do you mean by we have found what's indicated already. It's a weak acid or weak base. Don't care if we say acid, okay, easier to discuss. What does neutral means? Neutral does mean pH 7. No, not really. Okay, does not mean pH 7. Does not mean. We always say that, oh, neutral means pH 7. Not necessarily. So for indicator, of course, neutral point for water, of course, is neutral. We we say it's 7, but for indicator, it may not be true. So what does it mean by neutrality of an indicator? It means the concentration of HA. This one means concentration in moles per dm cube, okay? Concentration in moles per dm cube. It means the concentration of both HA and A minus are equal, same amount. That's why you have the middle color, right? Phenolphthalein is for very low pH, of course, it's colorless. Very high pH is red. That means that the middle point, when they are both equal, HA and A minus, is faint pink. Middle orange, red and yellow. The middle point, an equal amount, is of course orange. And of course, for your bromothymol blue, bromophenol blue, yellow and blue, middle point is green. Okay, so remember when they are both the same. So how do we calculate the pH? The pH at this condition. What's the pH? So we're going to find here. Now remember, this is your Kc. Kc, remember? Right, Kc or Ka, because it's an acid, is equals to your H plus concentration and your A minus concentration over concentration of HA. Why the whole thing? Because it's a weak acid, so there's a equilibrium here, right? So of course now we don't use A or C anymore. We use I, which means indicator. Okay, indicator. It means, well, just the abbreviation is all. Okay, so we put H plus as the subject. Bring up, bring down, this one here. So now at neutral point when HA and this is equal, so can cancel this out. Right? So concentration of H plus is equal to Ki, which is the dissociation constant of the indicator. Right? So if we put this one is equal to here, so pH is equals to log on here. So basically it's log minus log Ki, okay, or pKa. This is equal to, later you see here, it's very important, it's equal to pKa. It means at what? At neutrality, at neutral point of the indicator. Every indicator is different, okay, of the particular indicator. Okay, indicator. Okay, so for middle orange, you find the Ki is 2.1. So the pH at neutral point, right, when the constant is 3.7 now. Not 7. See now, the color change is around here, but there's always a window. Like here, I told you, middle orange, right? Remember, it's somewhere in the middle here is 3.7. So there's a window 2.9 to 4.6 where the color is orange. So below 2.9 is pink, or they call it red sometimes, okay? As I say, we use pink, always use pink, is red, always use red, okay? And of course, above 4.6 is yellow, right? So if you see that here, I put down the middle orange, right? 2.9 right here to here is orange, okay? So above 4.6 here, 4.6, 4.6, okay, 4.9, yeah, it's yellow. Now, if you take 7 as neutral, which is by definition, see, yellow color of the titration is not 7, no, is, just above 4.6. Of course, all this is yellow. So remember not, okay, orange color doesn't mean pH 7. It means that, well, the pH is about 2.9 to 4.6. That's it, okay, right? So the choice of indicator is very important, okay. Right now here, of course, phenolphthalein is about 7.7 times down here. This is the Ka. Of course, your pH for this faint pink is 9.1. See now, and so there's a window of change here. So 9.1 is somewhere in the middle here. 9.1. Okay. So 8.3, below 8.3 is colors. Above 10 is pink or red. So in the middle from 8.3 to 10 here is faint pink. Like I put down here. Right, see now, faint pink from 8.3 to here, okay, faint pink. So above 10, right, is pink or red lah, okay. So below 8.3 is colorless. See now, so if you do a titration with phenolphthalein and it turns colorless, it can mean 8 also, no. See now, so remember is the range, the neutrality of the indicator is it doesn't mean that it's pH 7, it's the range. Okay, to be exact, of course, you use a pKa. Okay, so here we can have all these things here, right? So we can actually calculate the pH when the indicator is neutral. All right, so I say there's a pH range of the indicator. Like all are given here, I just explained to you, right? So that means this range is very important, right? So at pH 7, the best indicator, of course, is your bromothymol blue, it's green color. Right? For middle orange is already yellow. For phenolphthalein is colorless. So different indicators will give different color at 7 pH neutral. It doesn't mean that a yellow color is always basic. It falls outside the range of 2.9 to 4.6. That's all for middle orange. Okay. So then this of course is the sharpness of endpoint. Like somebody say, oh, very sharp. Sharpness means the change in color is very clear. That's called the equivalence point. Okay, so you can see in your notes here, right? They actually use the word equivalence point here. Let me see. See, equivalence point. This is from Google. See, so you can see equivalence point. Okay, equivalence point, which means you're halfway between them. But don't worry about that. It's the point where there's a big pH change. It means a clear indication that the titration has finished, okay, or the clear indication from a color perspective that it has reached the end point. All right, so it's called equivalence point. Okay, so now of course the first thing is called end point or equivalent point. I call it sharpness. How sharp is it? Change color, very definite now. Okay, right. So how do you find definition of sharpness? This happens when a small change in volume, very important, 1 drop or 2 drops. Okay. Means a small change means 1 drop or 2 drops or half a drop. Sometimes you can put half a drop. Remember in the titration, acid to base or base acid near the end point will produce a big change. Small volume change, big change in pH, right? That means the big change in the H plus, I mean big change in pH, and it means a clear color change. It means you change your whole thing, the range in which the color change. After you have a look, okay, we see that. So it means a clear indication that neutralization is complete. Clear indication. So here it means a sharp endpoint means a small change in volume of the acid alkali, small change in volume, and it's a big change in your hydrogen H plus concentration or big change in pH. And of course, then you get a big color change. See all these small, large, and big, okay, color change and clear indication. So these are keywords, okay, small change in volume of titration, give a large change or big change in H plus concentration or big change in pH, give you a big color change and a clear indication that the endpoint is reached. Okay. So now we will consider how do we plot this whole titration. That's why it's called a titration curve, right? Like here, right? How do you plot this thing here? Now we're going to plot this one here. See, okay, here, strong acid, strong base. Anyway, it's a strong base. Okay. So this is the curve. It's called the S curve. No, look at S now. Not the S. Okay, it's S. Okay. Now I'm going to show you now there are 4 important or 3 important points that you need to consider because the marking scheme based on these 3 things. No, it's 3 points. Okay. The first, of course, is the pH at the beginning or before. The pH beginning, right? The pH at the end, and the pH at the end point and pH after the end point. Okay, after end point, which is the pH. So 3 pHs you need to know: before, end point, and after. 3 pHs you need to know. Okay, of course, then the volume of the end point, right? And also then the range. Okay, so it's the you can say 3 points. Okay, of 5 points. 1, 2, 3, 4, and 5. The pH range is very important. Now you have to memorize. It's very simple. Mr. Lai always say very simple because I'm quite stupid. No, I'm not clever. I'm just very smart. I know how to make things easy for you. Now there are 4 types of pH curves. You can see from here, 4 types. Right. So here, okay, strong acid, strong base, weak acid, strong base. All right. Here, you can see from here. Okay, this is this is actually weak acid and strong base, and the weak acid and weak base will be here. Like that. Okay. So there are 4 types of acids. Okay, right? You can see. I don't think I got it, but it means like that. Okay, it means S curve like that. Okay. Okay. Now mine. Right now this is a weak. This one is strong. See, kind of low is number 1 here. Strong acid, strong base, weak acid, strong base, and weak acid, weak base will come to here. 7, you just move to about here. Okay. So there are 4 types of curve. Very simple, right? So but now we need to know the pH, range. Okay, the range at the end point. Okay. So now here you need to, I'll show you first. So very simple. Strong acid, strong base, the pH range is 3, 7, 11, 3, 7, 11. Okay. Remember you go to 7-Eleven, the shop, 7-Eleven. So put 3 in front. So very simple. 3 to 7 is 4 units. 4 to 7 is 4 units. Okay. 4, 4, 4, Chinese say die, right? So 3, 7, 11. Okay. So for strong and strong base is the range, the jump. The jump is from pH 3 to pH approximately. Okay. You see the jump here. Like you see here, right? Yeah. The first one, okay. First one here. I see. Okay, so 3 to 11. Very simple here, right? The jump. Why is it such a big jump? Vertical shift. You see afterwards, okay? Right? Now, for weak acid, strong base, the jump is from 7 to 11, sir. Mr. Very smart, isn't it? Not clever, but smart. Or not smart, but clever. Don't care. Lah. Okay, so see now, the vertical shift, okay, for strong acid, strong base, 3 to 11. For weak acid, strong base, okay, 7 to 11. Okay, from weak base, from from strong acid, weak base. Okay, let me share. There's one here. Okay, here, see now. Okay, strong acid, weak base. Don't have here. She is here. Okay, 7, 3. See, strong acid here now. It's not here. Here. Okay, so strong acid is from 3 to 11. 7 here. Okay, later you see that. Okay, there are actually questions on this. Okay, so see now, 3 to 11. Okay, for weak acid, weak base, there's none. They just go like that. Yeah, okay, there's no vertical line. It's very hard to find an indicator. Okay, so the three of them have a sharp endpoint because there's a big change in pH, and so there's a big pH change right at the endpoint. At a small change in volume of titration, this is a big concentrated change of H plus, and there's a big pH change. Therefore, a big pH change, and will give you, of course, a big a color change. Okay, a sharp endpoint. Now we're going to look at this. I hope I can finish on time as well. Okay, now we're going to titrate. Okay, I'm going to show you the titration here. All right, I'm going to draw for you the titration. Okay, always draw the diagram. Okay, now here the whole thing here. Okay, I'm going to draw for you this thing here. Now, what you did, of course, in your AS is you got a burette here. Okay, a picture paints 1,000 words, you say. Okay, all right, and then you got your titration here. Okay, this is not the best drawing. Never mind. So what you do is, of course, depends on what you put inside here. Okay, so here, in this question here, considering put 50. Of course, don't put so much number. It's 25, isn't it? But put 50 because of easy calculation. Okay, so let's say this is the big, big burette, 100 cm burette. Okay, let's say okay. I mean, it's crazy. I don't think there's such thing. Maybe there is. I don't care. Okay. And then here I put this is a very large, it's a 500. Okay, normally it's 250, isn't it? Cm cube conical flux, okay? And I put inside here, right? I put inside here 50.0 cm cube. So I'm starting with here. Okay, the volume of my HCl is equal to 50.0 cm cube. And the molarity of HCl here is equal to 1.0. 1.0, okay, according to here, 1.00 mole per dm cube. Of course, at 1.0 dm cube, of course, the pH is 0 now, right? Right? 1 is it? Right? pH not 1 here, so 1 is 0, 0. Okay, so the pH is 0. Remember this, the pH is 0. Right? So starting. Right? That means I didn't put any NaOH yet. Okay, so of course now, why you get to use? Okay, first, okay. Then we start putting in NaOH. Okay, right? Now, of course, if you look at it here with HCl at the equation here, common sense, right? A bloody common sense, as they say. Right? 1 mole, so 1 mole. Obviously, if I use volume here is 50, okay, V1. Molarity here is 1. Volume, OH, why am I so stupid? Okay. Molarity here is 1.0. So, of course, the volume, the endpoint here will be also 50. I mean, common sense, because the number most we say. So, let's say we don't care, we are near the endpoint. Okay. After adding 49.9, very near the endpoint. We're going to count 49.9 and to 50.1. So there's a very small window here only of 0.2. Sorry, 2 minus how much is it? 49. Sometimes the calculation is horrible, I'll tell you. Okay, carry one here, 0.2 then, right? Right? 0.2, no, right? That means for about 4 drops, right? There's a 4 drops, and now, of course, if you look at it here in perspective, right, you think it's a lot, but it's not a lot. Now here, see, the blue line is the one I didn't have the time to copy whatever. Okay, now here, okay, yeah, right? Now, that means I start from 0 here. See, 0 here. Okay, so now here's the volume of, I don't use 0.1, I use 1. Okay, now of course I use the volume of this one here. I use the second one here. Okay, this the original one is if I use 0.1, I use 1 molar. Easy for calculation. Okay, so the pH of course here is 1.0 molar of mole per dm kilowatt of HCl. Okay, right now he started 1 here because why he used 1 here because he used 0.1 molar mole per dm cube of what? Of HCl. Okay, now, right? Just to let you know. Okay, so I will start here. Okay, so now you add 10 cc oil, you keep going up, going up. Okay, now after adding 49.9 here, which now 50 of course is the end point on. Yeah, okay. Okay, at the end point here, see, it's quite a long way, no? End point here from 0. What is the pH? Can I find the pH at 49.9? No, at 49.90 cm cube of 1 molar of NaOH inside. Okay, now, okay, now I can calculate out. That's what we do here. Okay, so calculate after adding 49.9 cm cube of 1 molar of NaOH. Okay, now, so of course we add inside here. If we add volume of NaOH, I put blue color so that you can easily distinguish. Okay, the volume of NaOH here is equal to 49.9 cm cube. Okay, masuk already, right? So of course, who is in excess? Of course, this is in excess. No? How much in excess? 0.1 cm cube. 0.1. I'm trying to hurry, because I want to finish quite a lot. Maybe cannot, never mind. Then we do 2. I thought of finishing the whole thing. Never mind. So I got excess of 0.10 cm cube of your HCl. See, okay, left over unreacted. Right? After adding this 49.90 of NaOH to react with 49.90 of HCl, 0.1 cm cube of 1 molar of unreacted HCl. So how many moles of it are there? Of this one here, of HCl inside this total volume now of what? The total volume is 50.00 plus 49.00 of what? Of 99.90. Okay, very near 100. So we use 100 side. It's easy to calculate now. Okay, so I got here the number of moles, right? And 100 cm cube of the total volume is how much? Is this one here. How do I know? Calculation one. Okay. Remember, number of moles equals to what? Number of moles of HCl unreacted equals to MVO1000. That's one. Okay. So M is how much? Original one is 1. Okay. What's the volume? What is the volume? 0.1 over 1000. Okay. So you shift here. 1, 2, 3. So 1, 2, 3. So 0.0001 moles of HCl in what? In 100 cm cube. Okay, right? So this number of moles of HCl in 100 cm cube of solution. So what is the molarity? What's the concentration of your HCl in moles per dm cube? Of course, it will be number of moles over volume is SR. Okay, so what's the number of moles? 0.0001 over 100 or 1000. Yep, because of course, some here, 0.003. So what's the pH? Of course, pH is 3. Why? Because pH is equals to minus log H plus. Yes, I do everything for you. See? Okay, minus, of course, this H plus is equals to HCl now. Right now. So, right? So it's equals to minus log concentration of this one here, 1 times the power of minus 3. Right? You bring out here, it's pH 3. So at very near the end point, it's pH 3, So from here, you can see, right, from 0 is going to, here is pH 3. Yeah, this point here, pH 3. Sorry. Wrong. Okay, let's plot again. Okay, put blue color, right? 49 is pH 3. Somewhere here. Okay. Okay, so first point here. Right, so actually you find each of them is gradual rise. Never mind. So of course at 50 it will be here, equivalence point. Why? Because NaCl is a neutral salt. Because why? HCl plus NaOH when it's finished, give you NaCl plus H2O. This is neutral salt. So this is bacteria is pH 7. This is also pH 7. So at neutral point it will be 7 at 50. So 3 and then 7 here. How about if I go 50.50 here, 50.1? Okay, just a one more drop here of 50.10 cm cube of your NaOH added. Okay, now I'm going to calculate again here. Right? So now after adding 50.1 cm cube of NaOH, which means it means here got 50 HCl. Now put NaOH is equals to 50.10 kilogram. Okay, it's about 2 drops only. Okay, right after here. Well, excess of NaOH, volume excess of NaOH, how much is it? It is 0.10 cm cube of what solution? Of 1.00 mole per dm cube. Okay, so what again? Number of moles of NaOH excess, how much is it? Right, MV1000. Okay, now, so what's M? The original concentration is what? 1 times the volume is 0.1 or 1000. Same thing, I'll get 0.0001 mole of NaOH in what volume? In 101. Cm cube. So approximately 100. Okay, that means in 100 cm cube of solution. Again, right? Some here. Okay, right? That means this is the molarity of the HOH minus. So can I find the pH? Of course you can. Remember not the ionic product of water. You have to know all this. I teach already. You don't know, go and die. I tell you first, don't study and you fail. Okay, so H plus here. All right, here's what? 0.001. Okay, equals to 1 to the power minus 14. So H plus how much? Equals to 1 times the power minus 14 over 0.001. Okay, right? So of course this shift 1, 2, 3, right? It will be 1 times the power of minus 11, right? So of course then pH is equals to what? Minus log base 10, of course 1 times the power minus 11, which is pH 11, yeah? Yeah, oh, 11, no. So the next point is here. Is very small amount here is gone to 11. Here, see now, here. This point here, I'm going to rub this off. It's not very well done here. Okay, so see now, right here. And of course, if I were to calculate for next point here, right? If you do the calculation here, for 51 is pH 12. Okay, that means 51 is pH 12 somewhere here already. Remember, the red color is for 0.1. Okay, mine is 1.0. Okay, so 1 is here already 12. And of course, it will go up to 14 somewhere here at the very end here. Very near here. Okay, so the pH graph, the pH curve looks something like this. It will go up. And at here, it will jump. The pH rises slowly, but it jumps. Like gold prices are shoot up. Big pH change from calculation. No, shoot up. One drop, a few drops here, and then go up to that. Yeah. So I'm just gonna get very accurate here. Never mind. Again. Okay, it will shoot up. Okay, somewhere here. Okay, see? That means this is past your endpoint already. So see this. So now this is called the S curve or the titration curve for strong acid, strong base. Right? The SK. So see now, I can plot the graph if I know I'm going to put red color, right? If I know the pH before titration, okay? For 1 molar is here, 4.1 molar is here, okay? Right, the end point, strong acid, strong base is 7, but don't care, you may not know, never mind. But you must know the end point, which is of course, in this case is 50, you can actually calculate out, okay? Because from the molarity and from the volume, you can calculate what's the end point, the volume of the end point. This is the volume of the end point, kind of volume of the end point, all right? 50 here, okay? So you know this point here. Then, of course, you know the pH of the after is here, 14. Okay, right? And then you must know what? The pH jump, isn't it? For strong acid, strong base, what? Is 3 to 7. So 3 to 7. Oh, sorry, 3 to 11. So then, now this point will be straight, vertical. They'll ask you to sketch. So you just sketch. Yeah. Go up. Okay. See now. Easy, isn't it? Okay, so this is how patient. Now, if you use, so the point is, what sort of indicators can I use, right? So let's say you got a titration here, all right? Let's draw again, and this is your, remember? Okay, this is your NaOH, this is 1.0 molar of NaOH, okay? This is your 50 cm cube. 50.0 cm cube of your 1 molar of HCl. So you add that, right? So let's say you put metal orange, metal orange. Okay, metal orange. First size metal orange. The first color here, of course, is what is red, isn't it? Or pink, red or pink. Red, I've got red. So as you add inside here, after 10 cm cube, remember metal orange, the color change is what? 2.9 or 2.6, I don't know. You can see from here. Don't remember, they will tell you one. You don't remember all these things. Right? See now. Here the window. Metal orange 2.9 to 4.6. Okay, 2.9 to 4.6, right? So 2.9. So this is 2.9 to 4.6. Right? So this is range is orange. Okay. So starting here after 10 cm cube, it still remains what? Below here, okay? Below is why? Because the pH is about 1 something. It'll be red. After 20, it's still 1.3 or 1.2. It's still red. 30 is still red. 35 red. All this red. After 40, it's still red. 2.1. pH 2 in. So after 45, it's still red. Right? When I add nearly 49.9, right? It's what 49.9 to be exact, right? 49.9. What's the pH already? 3, isn't it? Look at here. From our calculation is 3. Change already. 49 is still 2. See now, 49.8 is still if it's 49.6 or to 7 to 8, it still is what? It still is red. 1 point. 49.9 is of course near, it's very near the end point. It's not exactly the end point. Don't care, okay? That's why you see here the shade of orange is very important. Okay, never mind. Okay, it's 3. That means at this point you change color, you change color to what? To orange already. See now, see, right? 1 more drop. Oh, it shoot up. The color is shooting up. Okay, right? At 50, of course, it's 7 already. And 1 more drop, just a little above a 50.1, right? 50.1, see 50.1. 50.0.5 is 7 already. 50.1 is 11. See, and 1 or 2 drops is shift to yellow already, no? See, no? Yellow already. So it's very, so the choice of indicators so what are the choice of indicators? The choice of indicators, that means I can use metal orange, because such a big pH change. As long as the window of pH change of the indicator falls within here, right? From here, it'll be the pH is 3 to 11, strong and strong base. It means I can use what? I can use all this, right? As long as the pH change is there, right? See here, it means I can use phenolphthalein, because why? Because for strong and strong base is 3 to 11, right? 8.3 already fainting rate. Can use litmus, can use metal, right? Because it falls within the range, see 3 to 11. But I cannot use Thymol blue, right? Okay, Thymol blue cannot. Okay, but bromo Thymol blue can. Thymol blue, say bromo Thymol blue can. Thymol blue cannot, because the change is 1.2 to 2.8. Because that means it will give me orange at below 2.8. See not? Okay, cannot, because 2.8 is still acidic, isn't it? See, 2.8 is still acidic. Yeah, it's still acidic, isn't it? It's before the thing, before 550. So the pH change is very important, and to know the range, okay? As long as I can use bromo Thymol blue, right? 6.6 to 7, if it fall within this range. So for strong acid, strong base, I can use almost any indicator except like things that are below 3, okay, right here. Okay, now let's go to the next one. Okay, weak acid, weak base. Sorry, weak acid, strong base. Now I'm going to use another example here. You go over the video and then think again, okay? So now here I'm going to use weak acid. I just finished strong acid with HCl and strong base NaOH. Okay. So I'm going to use now weak acid, which is ethanol acid. I use many types. You see from past question. Okay, and weak acid and strong base NaOH. Okay. So of course the indicator here I said why. Okay. Now remember, this is the chain. This is what they will give it in exams. No, they will give it they will say here. The following data shows how pH change during a titration. When the aqueous NaOH, right, 0.1 added to 10 cm³ of aqueous ethanol acid. Okay, of course, here your ethanol acid, of course, is also 0.1. Okay, but of course here they don't give you what because I have to calculate. Okay, now let's see here. So your ethanol acid is here. You want to draw diagram, is here. Okay. Yeah, 10 cm³ only. Okay, so here the volume of the acid is 10.0 cm³. Of course, ethanol acid CH3 COOH. Okay, and of course here is your NaOH. Okay, molarity is a base is equal to 0.1. Okay, molarity. Yeah, so they added slowly. Okay, and this is the pH change, right? 0.0 means, right? That means before you add NaOH, this is the pH of your ethanol acid, which is about 2.9 or 3 because it's a weak acid, low amount of H+. Now, that means if I want to plot it, I'll show you what I do here. I use one of these things here, okay, to make it easy for me. Okay, can go faster, see? Okay, here, right here. Right, so remember now, all right, now this of course is the pH, okay, right, 0 NaOH, okay, so it's 2.9, so it's 1, 2 here. Now this is a different graph, what I use here, here is 2.9, okay, right, so 2.9, 2 is here, so 2.9 is here. See, I also plot wrongly here just now. Okay, now mine, we can plot again, no worries. Okay, 2.9 here. Okay, so the first point is here. So in exams, you'll be asked to plot, right? 2.9. It came out in paper 5. I probably asked you to do it. Now, after the 1 cm³ of the NaOH is 4. So here, 1 cm³. Okay, this is 2, 3, and 1, 2, 3, and 4. See 4 here. See. Okay, it's 1 here. Okay, 2 cm³, 3 cm³, and so forth. 2 cm³ is 4.3. Just a bit rise. After you see why, they ask you why. Okay, 4.3. Okay, then they talk about 4. They didn't go to 3, make it easier. 4 is 4.7. 0.7. So you 4.7. Okay, so 4.7 somewhere here. Just a little bit rise only. Okay, and then they give you 6 and so forth. Okay, it means okay, 7 is 5.5, is it? 5.5, 7.5, 7 here is 5.5. 7, let me check. I see. 7 is 5.5. 7 is 7 here. Okay, 5.5 somewhere here. I see I plot wrong here now. Never mind. No worries. Okay. Here's point here. Okay, any more not? Let's see here. 7 and then 8 is 6.4. 8 is 6.4. 8, 6.4. 6.4 somewhere here. Okay. And then any more not? 8.5 is 11.2. 8.5. 8.5. 11.2. See if it's 10, 8, 9, 10, 11.2 somewhere here. Okay, 8. Check again. 8 is 6. 8.5, 11.2, 8.5. 8.5, 8.5 here. 11.2. Okay. Okay. Right. So before that, I think there was an 8, is it? Okay. 8 is 6.4. Okay. 10 is 12. 10 is 12. 10 is 12. See, 12 here. Okay. And then, so this is what you'll do. 14 is 12.4. 14 is 12.4. 14 here is 14 here. See, I put wrong here, so here. 14. Okay. 14 is 14 here is 14. 12.4. 12. Okay. 12, 11, 12.4. Okay. 12.4 is not 12.4. Okay. So now, so what we do is we plot the curve. Okay. Ooh, something is funny. Never mind. Okay. So we plot the curve accordingly. Let me check again. See whether I missed 2.9. 2.9. Okay. So remember, now don't follow the black curve, okay? The blue curve. Okay. Okay, remember it's a weak acid, right? Strong base, so it's weak acid is 7. So 7, 7, 2. Okay. Now the end point, you don't know the end point, is not? See, you don't know the end point because they didn't tell you what. So you must plot that here. Slowly rise 7. Go up here. So now it is tricky because you don't know the end point. Okay. Okay. So now, in such a case, how do you find the end point? Very simple. You take the last 2 readings, okay? The last 2 readings here, here and here. Okay. What's the here? What's the last 2 readings here? Okay. You can go back here. Last 2 readings. The big change. Okay, which is here, you know. 6.4 to 11.8. Sorry. No. I mean the last endpoint. 8. 6.4, 11, 6.4. 6.4. Correct. 6.4. Right. 6. Let me just check. Volume is 8. Volume is 8. Okay, correct. 8. Okay, 8 here. 8. I didn't put 8. Sorry about this. 8 is 6.4. 8 is 7. 8 is 6.4 here. See, I don't miss here. No, I tell you. There's no 7, is it? Right? 7, 5.5. See, it's so easy to get lost. 5.5 is here. That's why this is a bit odd. So make sure as you plot here, all right? So here is the wrong point. Okay, so it goes like that. Okay, go up here. And here. Okay, so the last 2 points here, which is 6.4 to 11 point something, 6.4. Okay, this one here, right? So 11.2 minus 6.4, how much is it? You carry here is 8, 10, 4. Divided by 2 is 2.4. So you add here, 6.4 plus 2.4 is equal to how much? So 8.8. Okay, so the pH 8.8 will be the end point, right? So here, you put 8.8 here, about 9 here, right? Here, 8.8. You draw the line here and dot here. You go down here, and this will be your end point. How much is this? It's 8.5, around 8.5. End point. Okay, so this is how you plot the graph and how you determine the end point if you're not given the end point, which is the volume of your NaOH added. Okay, now, okay. So now this is the thing here. And let's go on. So you can see the S curve, isn't it? You can do this later, lah. Okay, right? All right. Now, so in this case here, what kind of indicator will you use? Right? In this case here, what kind of indicator will you use? Remember? Now, remember for weak acid, so the pH jump, we call it the pH jump, okay? Right? At the end point, pH jump for weak acid and strong base. Okay? Okay, so it's what? I told you 3, 7, 11. Weak acid means from 7 to 11. 7, yeah, 7. I put red color. 7 to 11. See now, around here. So what 7 to 11? What kind of pH window jump or color change can an indicator have to give you a strong change in color? That means, see, before 7, before 7, it must not change, no? Right? That means I cannot use meter orange. What's meter orange change for what? 2.9 to, forgot already. What? 4.6, I think. Right now, see? 2.9, 4.6. Check here again. 2.9. Here, 2.6. See? Right now, 7 already, that means the will go to yellow already before the end point. So cannot. So which one can I use? Of course, I use phenolphthalein. Because they changed from 8.3 to 10. Right now, so phenolphthalein is changed 8.3 to 10, 8.3 to, so phenolphthalein changed here. 8.3 to 10 here. It means it fall within the range. So I use phenolphthalein. That's 8.3 to 10. That means it will give me the change in color. That means before here, before 8.5 end point, like even here at 5 or 7 or 8 within here, here the pH is 4.6, no change yet. It's colorless. Okay, go to 8, no color yet. 8.4, 8.5, oh, the thing changed. It means very near the end point. The color changed to faint pink already. So the pH jump, right, must fall within the range of the change in color or the pH change in color for the indicator. In this case here, phenolphthalein. Right? Okay, 8.3 to 10. Anyone can use 8 point. Okay, you can also use okay, remember not a 7, okay, 7 to 11, I can also use, right? It's very near. Of course, the best, of course, is phenolphthalein. You clear? Right? Now, I got only 5 more minutes. Well, maybe I can finish this one here. Okay? Yeah. Right? Or maybe I just show the other one. Okay. Now here, for strong acid, weak alkali. Now, weak alkali, for example, ammonia. HCl. There's a question here, HCl and ammonia. Okay? Let's look at the question here, HCl, ammonia. Okay, weak acid, weak base, strong acid, okay? Weak base. Okay, now here's weak base, strong acid. Okay, now it's in the reverse form. Okay, right? Weak acid, weak base. So it can be the other way around. No, it means you start what? You start with your, it means here, right? You start with your any street, and you titrate what your HCl. No, it means at 0 HCl is 11.3. It's not 14. No, okay, it's 11.3 because it's a weak base, right? Okay, so of course now if the other way around, just show you. Okay, if the other way around, all right, that means the normal one. Okay, you use here. Now here got all the 4. Okay, now, okay, this is your weak acid. Sorry here. Strong acid, weak base, strong acid. Okay, here. Strong acid. Where's the strong acid? Okay. This fellow got it all wrong. See, I cut also, I forgot to see. I thought I got it. This is, of course, the full year, this is a weak acid. Okay, so I said, how come? Okay, this is your strong acid, okay? Strong acid. So sometimes you make mistake, okay? It's okay. Strong acid, it means that when you start, right now, when you're adding your base now, it means your, here is your acid. HCl is 1 here. So of course, this is 0.1 molar HCl. Okay, right now, that means it's your HCl here, and this is the starting point. Okay, strong acid, right? And the end point, of course, is here, near 25. Okay, right? Now this called the equivalence point here. Now you add one, you add here a weak base and ammonia. Okay, means after end point really is still about about 9 point something. 9.5, let's say. Okay, so it's a weak base. Okay, so the pH in the beginning 1, the pH at the end, right? And of course the volume about, let's say if this is 25, volume is 25. Okay, it means about 25 here. Now the pH jump for weak strong acid first and a weak base. Remember 3, 7, 11. Strong acid, okay, weak base. So from 3 to 7, 3. So the jump is 3 to 7. So you draw, just draw it up here and go up like that. Okay, right? So if it's a weak, now here's your weak acid, right? Your ethanol acid and strong base anyway. Okay, so from here now I forgot one thing. Okay, okay, 7 to 11. Now I just remembered. So I talk. And look at the time. It's time already. Just let me aim with this now. Now this is the actual one. Okay. Now this is the part. No. Okay. Now why here it goes up so? Why here it goes up so fast and then here so? Because at the half at the midway here. Now this is half. This is NaOH added. No, this is NaOH. The end point is 1 here. Okay. So at the end point is here. That means let's say this is your 25 cm cube of 1 molar NaOH added to the original one, which is your ethanol acid here. It's also volume here, your acid here is 25 cm cube of 1 molar. It means at halfway, which is your fifth, it's 12.5, okay, right? Is here. Now at this point here, why is the pH don't change much? Because this is called the buffer zone. Buffer zone. Why? As a midway here, remember, right? There's excess of acid, and there's all the salt formula. So there's salt of the acid and the weak acid is a sodium salt. It's not because why? Remember, some plus NaOH give you what? Give you ethanoate, sodium ethanoate plus water. That means this is formed. But half of this thing here is unreacted. That means your weak acid plus the sodium salt. That means this is a buffer. That's why it didn't change much. Here, this is called a buffer zone. Buffer zone. Because it contains the weak acid and the sodium salt of the weak acid. Okay? And halfway here, is when the pH is equal to pK. It's not because the concentration of HA equals to the concentration of the salt. That's how you find your pKa. Now I'm going to later. Okay, what I do, I thought I can finish now, but cannot lah. Okay, now here you can see here the question here. This is a very good question. It came from a book. Here the plot. Okay, now see, we'll do this question tomorrow, I guess. Okay, of that graph. Okay, now, okay, the whole thing here. If you got time, just read it. All right, so we finished today, and see you soon. But please go through the tube. Okay, you go to the YouTube, whatever. Make sure you understand, because this is a very important topic. All right, so goodbye, and God bless you. Okay, I'm ready to stop.